Good evening, dear students. Now I want to discuss allotropic forms of sulfur. It is two types: rhombic sulfur, monoclinic sulfur. Rhombic sulfur, other name alpha sulfur; monoclinic sulfur, other name beta sulfur. Now we will discuss rhombic sulfur, means alpha sulfur. This allotrope is yellow in color and its melting point 385.8 Kelvin, and its specific gravity, that is 2.06. So here melting point specific gravity rarely asking, so no need to by heart. And it is insoluble in water but soluble in carbon disulfide. This is very important point. Insoluble in water but readily soluble in carbon disulfide. And it also dissolves some extent in benzene, alcohol, either. Means some extent means yes, some percentage. Okay, somewhat it can be dissolved in benzene, alcohol, either organic solvents. So very important these 2 points: insoluble in water but soluble in carbon disulfide. Somewhat it can be soluble in benzene, alcohol, either, means organic solvents. So preparation: when roll sulfur in carbon disulfide, when it undergo evaporation, you will get alpha sulfur. This is preparation. So these are the key points regarding alpha sulfur. Now moving to beta sulfur. Beta sulfur, other name monoclinic sulfur. Its melting point 393 Kelvin and specific gravity 1.98, and it is soluble in carbon disulfide. Okay, its solubility only 1 point given in NCERT textbook. You should follow NCERT textbook. It is soluble in carbon disulfide. Now preparation. How can we prepare monoclinic sulfur or beta sulfur? Melting rhombic sulfur, means liquid rhombic sulfur we can take. When it undergo cooling, then precipitate like compound is formed. Means that is called crust. Then in that crust we can made some holes. In that holes we can pour that remaining liquid. Then we will get needle shaped crystals are formed. You can observe in diagram, needle shaped crystals are formed. Then if you remove that remaining crust, then you are getting needle shaped crystals of monoclinic sulfur we are getting. Understood? Very important. First one, melting rhombic sulfur undergoes cooling, crust is formed, that is one precipitate like compound. We can make some holes. In that holes remaining liquid we can pour it out. Then we are getting needle shaped crystals of beta sulfur is formed. So this is preparation. Now below 369 Kelvin alpha sulfur is stable. Above 369 Kelvin beta sulfur is stable. At 369 Kelvin both forms are stable. The temperature is called transition temperature. Clear? At 369 Kelvin both forms are stable. The temperature is called transition temperature. Very important, transition temperature. Just observe here, rhombic sulfur equilibrium with monoclinic sulfur. Rhombic sulfur means alpha sulfur, monoclinic sulfur means beta sulfur. Now just observe, above 369 forward means monoclinic sulfur more stable, above 369. So monoclinic sulfur means that is beta sulfur, above 369. Below 369 backward reaction means alpha sulfur, rhombic sulfur is more stable. At 369 both forms stable, that is called transition temperature. So this is very important point. You can expect question, what is the transition temperature? Okay, so above 369 Kelvin which is more stable, below 369 Kelvin which form is more stable? They are expecting questions. Now both rhombic and monoclinic sulfurs have S8 molecules. These S8 molecules packed to give different crystalline structures. The S8 ring in both the forms is puckered and has crown shape. Okay, particularly it is in crown shape, S8 molecules, how they are existed in crown shape. Several other modifications of sulfur containing 6 to 20 sulfur atoms per ring have been synthesized in the last 2 decades. So in the last 2 decades, and the scientists they were prepared each allotrope in which how much sulfur, how many sulfur atoms are there? 6 to 20 sulfur atoms are there per ring. Next one, in cyclo S6, so S6 form, cyclic form, the ring adopts chair form. Okay, and the molecular dimensions. So here SCI to remember crown shape, whereas S6 that is chair form. These are the stable allotropes, allotropic forms. So both rhombic and monoclinic sulfurs they exist in these structures. So crown shape and chair shape. Here bond angle in crown shape 107 degree, bond length 204 picometer. Please concentrate these two values. When you coming to chair form and bond length 205.7 picometer and bond angle 102.2 degree. So bond angle, bond lengths very important. Now at elevated temperatures means approximately 1000 Kelvin. Then that S8 or S6 they are converted into S2 molecules, individual discrete S2 molecules. That S2 molecule is paramagnetic like O2 molecule according to MO theory. You know MO theory, molecular orbital theory. Just observe O2 how many electrons are there? 16 electrons. So according to MO theory, molecular orbital theory, so 16 electrons means sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px equal to pi 2py, pi star 2px equal to pi star 2py, and sigma star 2pz. You know, according to MO theory, up to 14 electrons one formula, 15 electrons onwards another formula. Here 16 electrons means we can use the second formula. Now 16 electrons, how to write? Each orbital accommodate 2 electrons. So these are the degenerate orbital. Each orbital occupied by single electron and then pairing will be started according to Hund's rule. Now, so you can count 1, 2, 3, 4, 5, 6, 7. 7 to the 14. So 15, 16. So each degenerate orbital having one single electron. So there are two single electrons, two unpaired electrons. So it is paramagnetic in nature. So two unpaired electrons are there now. Two unpaired electrons are there. That's why paramagnetic in nature. Okay. Similarly, S2 molecule, oxygen, sulfur, same group. So that's why S2 molecule also, like you can write for S2 molecule MO theory, you can write valence electrons. That is enough. Then that is also paramagnetic in nature, like O2. S2 molecule also paramagnetic in nature. Understood? So these are the very important allotropic forms. So I hope this video very helpful to you. Clear everyone? Yes. O2 molecule is paramagnetic. Similarly, S2 molecule also paramagnetic. You know, at elevated temperatures, that S8, S6 converted into S2. That is the dominant particle. S2 existed. So it is a paramagnetic based on MO theory. Okay, thank you. Thank you so much.